Okay, good morning. Welcome to
FamilyMath932.
FamilyMath932. So last week, although this was posted a month ago, last week I saw this really neat U.S. climate change at the county level article by John Chonder. And I don't know who John Chonder is, but this is a really terrific article, and it's a great example of a really cool way to use Mathematica. So the graph that we're looking at, maybe I can zoom in on it so it'll show better on the screen. This says change in mean annual temperature for U.S. counties 1919 to 2018. So what I think, based on my understanding of what this article is about, what I think he did is he took the 10-year average temperature by county starting in 1919, and he took the 10-year average temperature ending in 2018, county by county in the U.S.
All right.
And this is this graph or this map displays, so the lighter colors are very small temperature change,
Alright.
and as it gets progressively darker, it's up to above 4 degrees Fahrenheit down at the bottom. So the very first thing I would ask you is take a look at this graph or this map or chart or whatever we want to call it, and tell me something or some things that you notice.
Well, there's just kind of this weird one white box here around. There's kind of surrounded by like all red, and then there's one county that's just white.
Okay, what's something that you think could account for that? That's an interesting thing to notice.
And just maybe they don't have data for that county.
Yeah, that could be. Maybe they don't have data for that county, or maybe, who knows? Maybe just by strange, temperature variations. Just it so happened that in that county it wasn't as big of a change.
Interesting.
Okay. Anything else that you notice?
Looks like sort of like kind of southern between the east and the Midwest, kind of in that area. Looks like it's kind of affected the least, and then more towards the west is affected the most.
Okay. Interesting. Yeah. How about some things you notice?
It looks like I know there's a bunch of like deserts and drier areas here, and that looks like it's warming more.
Okay.
And then here's a bit wetter, like there's more rain.
Yeah.
It's warming less.
Okay.
And then it kind of looks like the colder areas are warming more, and the really warm areas are warming more.
Oh, okay.
Like it's colder up here, and like that's pretty warm here and up there, and down there too. But this is warm.
Yeah, neat. Okay. So good. So what we're going to do is we're going to go through this, and I'll just show you the data before we go through it. And then I'm going to show you luckily John Chonder shared all of his Mathematica code, so I was able to come close to replicating this chart, which seems like it'd be impossible to do, right?
Mm-hmm.
Yeah.
Like what an amazing chart. I was pretty close to replicating it, so I want to show you. We'll walk through his steps. But first, I just want to show you the data, which is here, and probably not that great on screen. So let me scoot that over. I'm not sure if that shows up better or not better. Let me go up to the top of it. So what we see is we have some data, which is a code here. So I'm pretty far away from it, but I think it's a 010010021895.
Mm-hmm.
Yep.
So it turns out that this code, that 01001, helps you identify the county, and 021895. What do you think that is?
No, 1895 is probably the last 4 digits and maybe the year.
Yeah. So, and what do you think the 02 is?
They all seem to have the O2.
Yeah. So, yeah, I don't know. So one thing we have to do to understand this data is to get the code, and then maybe it's actually the first 6 digits are the code, and then the year. Maybe that's what identifies the county.
Yeah.
And then it's January, February, March, April, May, June, July, August, September, October, November, December. The average temperatures. So that's the data.
All right.
Okay. But one thing that's going to be important to remember is this code begins with 01.
Okay.
All right. So let's go on and look through the Mathematica stuff now.